Just keep breathing. Breathe out, breathe in. Relax and give in. Can you picture you and me in the darkness? Kissing, touching. Kill the lights, I'm your assassin. No sleep.
This is a video that I have put off for far too long. It's a video that's been requested many times. I continually avoid it, and the reason why is that this information is extremely difficult to properly convey and condense in video format. But we're going to give it a try. Hello everyone, my name is Greg with Primal Rights, and we are going to talk today about neck turning. The first question some of you may have is, what is neck turning? Well, neck turning is basically shaving material off of the outside diameter of the neck and or the inside diameter of the neck, and some might call that neck reaming. But the overarching theme here, when we say neck turning, we are typically using a cutting implement on our necks from the top of the neck to the bottom of the neck. So basically the neck-shoulder junction of the case up to the mouth of the case. Now that we've established what neck turning is, why would we want to do it? Well, when you reach a certain point in your shooting, you will invariably come to the conclusion that the rest of us have, that are shooting at that level, that the brass is probably our primary limiting factor in the performance of these rifles at this point. Our knowledge of the brass, our execution of various processes, and the level of equipment that we bring to bear on the processing of our brass is by far and above the most labor-intensive and most critical element of creating ultra-high precision hand loads. So whether we're talking about the resizing of the case, the subsequent tumbling of it, the annealing of it, the use of certain dies and their general design properties and surface lubricity. Folks, I have a tremendous body of work on our channel that deals with brass and its various properties. And frankly, I don't know when I'm going to get done talking about it or producing content on it, simply due to the fact that it is such an extremely deep and complex subject. And our success as precision rifle shooters has a lot to do with our knowledge of the brass. And so I'd encourage you to go look at some of that previous content if you haven't seen it already. All of that content, as well as very much more that I have not produced yet, is almost required to have a full and total understanding of this neck turning operation, what we are doing, how we are doing it, and why we are doing it. So the most logical place for us to start is probably why. Why should we neck turn? The reasons why you would want to neck turn seemingly all stem from a few issues that the brass has. And so the nature of how this brass is made, typically it starts from a flat sheet of material which is stamped out into discs. Those discs are then formed into cups. Those cups are then, through a long series of processes of being drawn through dies and hit with various punches and drills and equipment, is processed into brass. Now there's quite a lot of YouTube content out there where brass manufacturers give tours and various other things to different creators, and you can see how some of these different factories produce brass. That would be cool for you to go and see, just because understanding the processes of how it is made, you could very easily see how, because of how it's made, in order to be mass produced in appropriate quantities and delivered to the masses at somewhat a reasonable price, this stuff has to come rocketing out of these machines in some pretty high velocity and speed and quantity. And so there's a number of things that happen during the brass manufacturing process that leads to non-uniformities. Now, the non-uniformities are what we're addressing here with neck turning. The non-uniformities that exist in our brass, we're constantly combating this, because if we have a perfect rifle system, perfect bullets, perfect powder, perfect ignition and primers and such, in that theoretical, seemingly unattainable perfect world, the brass then would be our last source of non-uniformity. Neck turning then is how we address the removal of that non-uniformity in our necks. So the why we would do this comes from quite a few places. Obviously, the first why is just to eliminate non-uniformity. We want as much uniformity in every aspect of our shooting as we can get, because the more uniform we can do something, the more predictable the outcome is. And it stands to logical reason then that as we remove a non-uniform thing from our process, whether it be something that we can measure or something that by volume exists that we have difficulty measuring, then we would want to do that. And most other things in the discipline will track with that relatively well. So anytime we can remove non-uniformity, it's a good thing. Way back in the day, a lot of shooters were thinking that a extremely tight fitment between the loaded round diameter at the neck, so with a bullet in the brass, we take a diameter measurement on the outside diameter of the brass on the neck, and they wanted that fitment to be extremely tight to the chamber dimension, so the neck diameter in the chamber. If you tried to load factory ammo, it wouldn't actually fit, because the brass would be too thick to go in there. And the reason why they were doing that is, at the time, it was thought that that tight fitment kept everything more aligned. And as a result, rifles would shoot better with a tight chamber and a tight neck turn. And so the control of both of those elements allowed them to get rid of the non-uniformities in the neck on the brass itself, then also control the expansion, right? Limit the amount of space that that brass had to grow. And it was thought at the time that that was critical to accuracy and precision. Obviously, as time has progressed, we found that to not be true at all. We can actually get things shooting extremely small whilst having a hot dog down a hallway effect for our ammunition to some degree. Obviously, I embellished there a little bit, but the long and short of it is I have some rifles here that will shoot sub 2s at 100 yards, and they have like 6, 7, 8 thousandths of clearance between a loaded round and the chamber. So obviously this doesn't live in a vacuum. All of those variables, the neck diameter variable doesn't exist on its own. You need to take other considerations into account when making those decisions. So I'm not saying that the neck turn chamber thing doesn't work. I'm just saying that we've had kind of advanced past that, where we don't find it to be such a requirement. But that is one reason why you would have to neck turn, because if you think this through logically, your rifle chamber being so small that you can't load factory ammunition means that you won't be able to grab virgin brass, load it up, and chamber it in your rifle either. So if you can't physically chamber it, then it is, of course, not going to work. And then, more importantly, let's say that you can chamber it, but there's only maybe 1,000th or 1,000th and a half of space for that brass to expand to meet the chamber walls. in that instance, you will almost certainly have a very high pressure because the brass will not be expanding enough to fully release its grip on the bullet, and you will have a absolutely catastrophic pressure spike if that interface is not manicured well enough. So the necessity of neck turning, if you are running a neck turn chamber, would seem relatively obvious. Now, there's a lot of you out there that are having rifles built by smiths that might not be so tuned in to this fact. And for instance, the 22 Creedmoor that I know and love is one of them that has been plagued with this issue. One of the first chambers that I ever ran in 22 Creedmoor had a 257.5 neck diameter. That means 257 thousandths and a half, essentially. So, you in reamer design, you get down to right on the 10,000th, if you will. So 257.5, that last fourth decimal place is essentially our 10,000ths. So we've got 5 10,000ths or half of a thousandth over 257 diameter. The brass that came to be, right, at that time we were mostly having no choice but to neck turn for our chambers. We were sizing down from 6.5 Creedmoor cases, and when sizing down from 6.5 Creedmoor, you've got to go down to 6 and then down to 22. And during that process of making the diameter of a pre-existing neck smaller, you will increase its thickness as well, because that brass will flow around the perimeter of the neck and it will get thicker, right? So as we constrict it, it's going to be growing in length ever so slightly, and it's going to be getting thicker ever so slightly. So it's not very uncommon to start with 6.5 and end up at 22 and have picked up a thousandth or a thousandth and a half of neck thickness. Now, when used in a chamber at 257.5, folks, that's going to be way too tight. And so there's a lot of people out there running 257.5 and 258 chambers on these 22 Creedmoors right now. And as is often the case when people are following in other people's footsteps, oftentimes they lack the first-hand experience to understand what kind of complexity that's going to be placing on the end user's life. These days, I would recommend nothing less than a 260 thousandths or 260 neck diameter for a 22 Creedmoor. Obviously, your brass thickness consideration is what you would use to decide this, but a 260 diameter is perfect for a modern 22 Creedmoor with factory ammo or any of the aftermarket head-stamped brass offerings. And it's certainly not too large. Point in fact, there's a video on my channel of shooting a 3-shot group at 100 yards in the zeros. I believe it measured 0.7, so less than a tenth of an inch at 100 yards that I shot on camera. That was with a 260 neck. So that reason why to neck turn has kind of gone away, but you could just measure your fired round neck diameter and compare that to one of your loaded round neck diameters, and you would be able to determine for yourself whether or not that would be necessary for you. So the first one we've got is just to remove non-uniformities, and the goal there to gain some potential access to a higher plateau of accuracy and precision by doing so. That's obvious. And the second one, a mechanical necessity, meaning that the rounds simply will not function in our rifle unless we get some of this neck material turned off, get our neck diameters down a little bit. Now, another reason why we might want to neck turn is to alter how our rifles shoot, so as a function of load development. Obviously, a thinner case neck wall will probably lead to lower bullet seating forces than a thick neck wall would. Thinner cases are going to be able to be annealed much quicker because there's not as much material, so it won't need to be as long of an annealing process. And so a combination of these things, you can almost think of the neck turning process as another series of switches and levers that you can pull to get a desired outcome with your load development efforts. So just like altering our annealing setting or altering our bushing or mandrel diameters, powder charges, think of neck turning as one potential way to unlock different kind of performance and allow your rifle to come into a tune better or easier. Now that we've established why we would want to, let's try to learn how to neck turn. And in order to do that, we have to understand where the imperfections lie and how to measure them. We want to identify whether or not we need to neck turn before we do the process. Now, the first and most obvious, and this is the one that is easy for everyone to understand and kind of why they think they need to neck turn in the first place, is the brass wall thickness. So around the circumference of the brass, the wall thickness will vary from one side to the next. This imperfection happens very simply during the forming process because the material and the machines and the dies and the tolerances of all these things, the skill of the operators will put a non-uniformity into the thickness around the circumference of this brass. So that essentially means that one side of the brass will be a different wall thickness than the other side of the brass. Obviously, this can take many forms, little bumps, little raised ridges. The equipment and the way that these imperfections can happen in the material thickness itself is almost unlimited. So the wall thickness, pretty easy for everybody to grasp, and we neck turn it. We want to uniform the thickness around the circumference of the brass, right? Very easy to understand this element of neck turning. This is as good a time as any to talk about brass neck thickness. If you've already made the decision to neck turn, then what dimension should you be turning to? Just how thin should you be making these necks? Now, the answer to this is going to be relatively cartridge specific, because on the bottom end of the spectrum, say with like Hornet cases, I've heard of guys making their necks 8 thousandths thick down there. Now, I find that to be a little bit crazy. That's very thin. Now, on the upper end of the spectrum, then all the way to 50 BMG, well, you'd have to use your own judgment on your specific use case there to determine how thin you should make these things. So for standard cartridges, most stuff that most of you are going to be shooting, you'll probably end up shooting for a finish turned wall thickness of somewhere around 12 thousandths. Now, your decision here on what you're going to use in terms of thickness will be dependent on your specific application, what your goals are for your neck turning. And so you don't want them so thin that the slightest little ding will cave in the neck, and you don't want them so thin that it starts having problems like split necks or things like that. Your process that you're using throughout your entire ecosystem is going to depend on your choices here. So if your process dictates that you need to turn to 10.5 or 11 thousandths or something, well, then you can make that decision. Hopefully this video will arm you with enough information so you'll know how to make that decision by the end. Most of the time when I'm turning, the vast majority of my cartridges, I'm shooting for about 12 or 12.5 thousandths. And I find that to deliver kind of the best result that I'm looking for on target. It gives me the bullet seating force that I'm looking for, and it's generally just fairly easy for me to get there when I'm starting with brass that is on average 13.5 to 16 thousandths thick, which if you measure most of the brass out there that's being offered for cartridges that you're familiar with, most of that brass is going to fall kind of right in between their neck wall thickness on average, maybe 13.5 to 15 or 16 or something. The recommended policy then when you're running your neck turning machine is to kiss off on the shoulder of the brass as well. So we turn the entire neck and then we turn some of the shoulder to remove material thickness there. The reason why, obviously, as we cycle these cases through our process, they will grow. They grow because as we fire and resize them, the brass gets pushed out the top. And that brass flow will carry thicker shoulder material up into the neck. And so how much you kiss into the shoulder there and remove material at the shoulder is kind of dependent on how much thickness it has there. And it's very difficult to measure this. You'd have to get a measuring implement inside and around the corner and measure and essentially pinch that against the shoulder. And there's just not much in the way of accessible tools to the average hand loader to do that. So as this brass flows up into the neck, the idea is that you want the same thickness of material to flow up into the neck. Now, with Wildcats, it's wonderful because you'll see in this video, I do not turn the shoulder. I just barely touch the radius at the bottom of the neck. And the reason that I'm doing that is because my Wildcat, I'm necking these things down. I'm starting at 6.5 and necking them all the way to 22 caliber. So when I do this, part of that neck that I've already turned will become shoulder material. So I'm building this aspect into my process already, and I'm choosing to turn the cases at a larger diameter and then make smaller diameter cases from them. If you were not doing this and you were turning 6mm cases that are going to be used in 6mm, well, then you would probably want to take some of that shoulder material as well. So this removal of material to uniform the thickness counts not only around the entire perimeter of the case, but from the top to the bottom of the neck as well. We don't want just uniform around the circumference at one point of the case. We want a uniform from the top of the case mouth down to the neck shoulder junction. Okay, uniform thickness there, and then turn some of this shoulder material as well. Now, how thick are we talking here? Okay, well, folks, when we're neck turning, we are literally splitting hairs. The average thickness of a human hair is between 1,000th and 3,000th of an inch in thickness. And here we are oftentimes talking about removing maybe 1,000th, maybe 1,000th and a half of material, sometimes even less than that. So when we're talking about neck turning and changing the thickness and uniforming the thickness of our neck walls, we're taking something that's starting out between maybe 13 and a half or 14 thousandths all the way up to maybe 16 or 17 thousandths, like the thickest of the brass. Obviously the big giant cartridges would be slightly different here than smaller cartridges. We're talking about maybe an average of say 15 or 14 thousandths, and turning that down to like 12 or something like that, maybe 12 and a half thousandths. So we're not talking about a gigantic thing here. And the skill and knowledge that is required to do something like this effectively, folks, this is the stuff that machinists will sit there and toil over for 5 or 8 years apprenticing under someone else to learn how to do, because it is extraordinarily complicated. The machinists, they have to sit here and do this with all kinds of material types, all kinds of cutters, and all different configurations of that material. So it's infinitely more complex for machinists. For us as hand loaders, all we're dealing with is brass cartridge cases here. So we can get some very specialized knowledge for this specific application that will be a lot easier than what a production machinist would have to have in order to be good at their job. So don't be scared away by how small of a thing that we're talking about here is. It's actually fairly simplistic and straightforward to do if you have the right equipment and you're armed with the knowledge. And that's what we're trying to do here on this video, is get you armed with the knowledge. The next variable that we're going to talk about is circularity or roundness. And so we could have the most consistent neck thickness in the world, but what if the shape is oval, right? What if it's not round? What if instead of being round, it's kind of oval shaped? And so the roundness of our necks is something that we want to be concerned with, because we don't want a non-uniform pressure being brought to bear on the bullet during bullet insertion, where it's riding on one side of the neck and not the other. Granted, some of my previous videos on how to choose your diameters of your bushings and your mandrels and things will help prevent this by a large margin. But the idea here is that we want to have a very round neck ammo configuration. Now, circularity is kind of what we use to measure this, and the issue here is that a neck wall thickness variance can create a circularity problem. So the two things are very joined together, and you'll find that as I pick through these variables here, you'll find that they're actually all connected to each other in one capacity or the next, and so that if one of them is wrong, it will create a compound error, making the next one wrong, which will then compound and make the next one wrong still. And so any one of these variables not being right by itself is a problem. All of them being wrong together, of course, produces some of the worst ammunition imaginable. So our roundness, and whether or not the ID and the OD is an actual circle, that's kind of what we're talking about here. Now, the terminology that I'm going to be spitting at you as far as what these things are, some of that can be used interchangeably in a standard conversation about neck turning, and most people will understand what you're talking about, but it is important that you get the details here because they do matter. So circularity or roundness is basically a 2D tolerance that is basically a single point that you're measuring, and think of a singular layer of a cross-section of your cylinder or a cross-section of your tube, right? And that's essentially what we're dealing with here. If you want to throw some machinist ideology at this, you're going to want to look at machining tubes, because the tube is the most likely representation of our actual case necks that we're dealing with. Cylindricity is the next thing that we're going to talk about, because now we're talking about roundness in the 3D. We're not talking about a 2D cross-section anymore. We're talking about the cylinder as a whole. So it has a top, it has a bottom, and it has the circumference. And the roundness across the cylinder is how we deal with our height variation. So from the top of the mouth all the way down to the neck-shoulder junction, that cylindrical nature, that cylindricity is going to address, will allow us to measure those things and get a larger picture of the total error. So not that it's just round on its cross-section, but that it's straight along its axis for the entire length of the part, in this case, the neck of the case. The next term that we're going to talk about is coaxiality. Now, coaxiality basically means whether or not two cylinders are aligned with each other. So if you could think of the ID as one cylinder and the OD as another cylinder, let's say that both of those were tubes, and those two tubes had perfect wall thickness. Well, where are they aligned to each other, right? So if we've got two necks coming together here, and is one offset this way or this way or this way? And of course they'll move on that axis, right? So they're parallel to each other as far as the through bore, but they're off axis in one way, shape, or form. But what if they're pointed off axis, right? So now instead of being like this, they might be perfectly centered in the middle of our cylinder, but they're pointed away from each other. So this being straight up and down, this cylinder is pointed off this way. Now this is a very extreme example of what I'm talking about, because when we go to seat bullets, this will often happen to us as a function of a poor seating stem, or imperfect bullets, or very bad seating methodology, right? If the top of our case mouths are not manicured correctly, we can go to seat a bullet and the bullet will be off axis, and it will stay off axis and get pushed down in like this. And that will, in the case of inferior equipment specifically, that will pull the axis of the neck off. So the through bore of our case does not go perpendicular from the top to the bottom any longer. Instead, the through bore of the case maybe is straight here, but then veers off up here in the neck area as the neck material has been deformed and kicked off to one side. Now, that can happen during the bullet seating op, but also it's important to know that right out of the box from the brass manufacturer, that coaxial alignment problem can exist, where you've got a perfectly good cylinder, you've got a perfectly good tube, and it's uniform in thickness, it's got good roundness, it's got all the other attributes on it are good, but the hole that's in it isn't perpendicular to the base of the case. Now, when we actually measure this effect as it applies to us in hand loading, we are using what is called a concentricity gauge. Now, the concentricity gauge is typically going to be taking a reading at one specific spot. And because of that, we're essentially getting a 2D cross-section of wherever we're measuring along the length of our cylinder here. And the concentricity is basically going to be a compound effect of the previous elements, because those previous attributes, it's not like they went away. So if we have a neck wall thickness variance, well, that could be creating a roundness problem, which could then be creating a concentricity problem. However, it doesn't have to necessarily be that way, but it almost always is because we're dealing with a tube. And guess what? If the ID is offset from the OD, well, then that's almost universally going to lead to a thickness problem as well, or a roundness problem, right? It's very obvious here that it would be very hard to move that hole to one side or the other without having some sort of a thickness variance or a roundness problem, a circularity problem. So you can kind of think of concentricity here, as it's commonly thrown around in reloading circles, as the total combination of those previous two elements. Because either one or both being present, you've got a concentricity problem as a result. The aspect of cylindricity, obviously, is whether or not that concentricity issue runs from the top to the bottom, or if it's only on one spot or not. This is where the rubber meets the road for neck turning, folks, because this going flat against your bolt face, this being centered in your chamber, and that bullet being pointed straight down your barrel, this is where the primary accuracy and precision benefits from neck turning can be drawn from. So this coaxial alignment issue that's created by this neck pointing somewhere else than perfectly straight and perpendicular to the axis along our bolt face here, or the base of our case, right? That coaxial alignment is absolutely critical to unpacking the most precision and accuracy that we can from these systems. Now, the next piece of terminology that I'll throw at you is run out. Now, this is something you've seen thrown around a lot. Obviously, run out, most of the time we're referring to total indicator reading. And basically, we take our cartridge, we stick it on a runout gauge, and we rotate it. And so we're taking a reading somewhere on a cross section, right? We're taking a 2D measurement across the cross section on one of these places along the case. And the case sits on an item, a support structure of some kind, whether it be roller bearings or V-block or whatever. We rotate the case and we determine whether or not the compound error of all of the previous effects is showing up anywhere in this composite, right? Because we're combining all of that stuff now into a single reading, essentially. And you can take a runout measurement anywhere along the body of the case. You can take one here on the neck, anywhere along the neck. You can take one on the bullet itself to measure where your runout is coming from, right? If if you just want to take a 60,000 foot flyby and look at your ammunition and see whether or not it's kind of straight, then that's one way that you can go about it. Now, I will tell you, this is probably one of the most misunderstood aspects of hand loading. The terminology being used, run out, and how people are throwing that term around, what they're actually measuring when they go to do it. It's very important to understand the differences between this different terminology when trying to learn how to actually neck turn and get a real world benefit from it. Now, those of you that are machinists out there are probably sitting there screaming at your screen right now because the way that I'm describing some of these terms don't line up with what you've been taught or what's in the books, or folks, you have to understand my goal here, right? My goal is not to teach machinists on how to do their job. My goal instead is to teach hand loaders how to neck turn and do that in a way that's very accessible to them, that will teach them how to get the most out of this process if they choose to do it. So I apologize if some of these terms are being used in the wrong context. However, it's important that we move past that just because, for the sake of brevity, there's a lot of machining resources out there if you wanted to take this to its farthest reaches, okay, folks? I'm by no means an authority on that. My goal is to shoot better, and that is the context that I have used these terms in, and that's the way I'm wanting to explain it to people. So don't take my word for this stuff in terms of the terminology used or the way that I described it. If it's not clicking for you, you should probably seek out a more advanced machining-oriented resource. However, the goal here is to produce straight ammunition, and understanding these various terms will help you do that. Now, the various pieces of equipment that you would use to measure this stuff is, first, you're going to need a micrometer. And a micrometer will allow you to very precisely measure your neck wall thickness. And these, you can typically find a micrometer that will resolve down to 50 millionths. So 50 millionths is the 5th decimal place. It's so if you were to think of half of 1/10,000th, that is 50 millionths, okay? So that's the 5th decimal place. The 4th decimal place, now we're at 10 thousandths. The 3rd decimal place, which I'm sure all of you are familiar with already, that is thousandths. Then, of course, hundredths and tenths. So very basic instruction there on how the measurements work. Now, the reason a micrometer is so important is because it's measuring a very short, small area. Like a very big micrometer is like 1 inch, right? Those that are available at a reasonable cost anyways. You can expect to spend somewhere in the neighborhood of $350 to $500 for a good micrometer, and I would recommend getting a nice micrometer stand to go along with it, because the last thing in the world you want to be doing is holding both the measuring device and the part that you're measuring, in this case the brass, with our hands. Folks, we are trying to measure something so infinitesimally small here that if we have any possible chance of getting this right, we have to take all of the steps that we can to make sure that the measuring setup is as stable as possible. So you don't want this thing wobbling around on a rickety bench or something like that. You want this measuring setup to be very, very rigid. And better still, if you can support the case properly when taking your measurement as well. That can be much more difficult and will take a lot more knowledge on your part to set that up properly. Just to put this in context for you folks watching this, in a machining environment, when we're talking about holding 2 10,000ths, oftentimes machining companies will invest somewhere between $250,000 and $500,000 in order to get measuring robots and sensors and setups and granite plates and all this stuff. The amount of investment that it takes in order to measure consistently beneath 3 or 4 10,000ths is quite dramatic. And it takes high-level knowledge by the operator to even use those things correctly when we're talking about that small. So just don't think that this is just some super easy thing that you can measure. You will have to invest in some equipment here in the form of measuring equipment to even think about taking this measurement correctly. Folks, if you think you're just going to pinch the neck with your caliper and get this measurement correctly to the way that it will benefit you maximally in shooting, that is just not a reality, okay? That's not going to happen. So if some of you out there are thinking that right now, I hope you've watched this and I hope you stop even pursuing it at that point. So you will need a good micrometer at the bare minimum in order to take your proper neck wall thickness measurements, and a ball micrometer or a tube micrometer is what I would recommend to take these readings. Obviously, a ball micrometer will allow you to take a more accurate 2D cross section where you can just measure tiny little points along the thickness from the top to the bottom of the neck. And then a tube micrometer, well, that will give you the ability to read basically the totality of the entire neck, and you might have some individual 2D axis roundness error there. But in general usage, I find either a tube micrometer or a combination of a ball mic with a flat anvil is oftentimes a good way to go about it. And obviously it can be a flat anvil or a flat stem. It doesn't really matter which, but you can see here that the micrometer that I'm using is a ball on one side and a flat on the other. And so that allows me to take some pretty consistent measurements. And so I would defer to somebody with much more experience than I to say which one is for sure the better implement to use. The point here is get a micrometer that you can trust. And it kind of goes without saying here, folks, just like everything else, and with our PrimeWare primer seating depth measuring device, a $35 Taiwanese micrometer is not going to be the same as a really high-end Starrett or Mitutoyo or something like that. So use your deductive reasoning here, folks, and don't think that you're going to be able to just get some cheap micrometer and it's going to be sufficient. A concentricity gauge is the next piece of equipment that you would probably want to have, but to neck turn in its totality, if you're neck turning the right way, you probably don't actually need a concentricity gauge. Now, without a concentricity gauge, however, you wouldn't be able to detect a concentricity problem. Now, would you? I won't be actually endorsing anyone's reloading-oriented concentricity gauge here on this video. And the reason for that is I find them all to be quite lacking, and instead I would opt for setting yourself up with a more like machinist or machine shop type of concentricity setup, using some flat surfaces and some implements of your own choice. I may do a video on that sometime in the future, but we'll see how well this neck turning video is received, I guess, whether I'm going to do a deep dive on that in the future or not. I think that there's going to be relatively few people that this video will actually help, very few people that will be engaging in neck turning. But it's worth it for the academic exercise anyway, because those of you that are looking for the highest possible echelon of precision rifle performance, you will need to know this stuff. I would not be able to shoot the way that you've seen me shoot in multiple different videos had I not had this information. Even if I elected to not neck turn for those cases, I still needed to know this in order to make sure that that ammunition was correct. Now, the next and most obvious piece of equipment for neck turning is a neck turner. I think that probably is relatively obvious for most of you. The discussion on which neck turning implement to use has been one of those where, due to how difficult to quantify this process is for most people, and how the benefit to be had from neck turning has delivered relatively lackluster results for a lot of people over the years, the neck turning tool choice has become ultra polarized. You have to have a more advanced knowledge base of what we're doing and what our goal should be when neck turning, and what characteristics of the rifle brass are going to be producing the best results. in order to produce the accuracy and precision that we're looking for, right? How these things come together. For instance, if we were to take one variable off the table and say coaxial alignment, if we were to ignore coaxial alignment and we were to say that the cylinder or the 2D cross section of the base of the case, right? So think of the base of the case as just a circle, a 2D circle. And then think of the case mouth to shoulder junction as a cylinder. Is that cylinder perpendicular along its axis to the base of our case? If we were to look at that alone and take it off the table and say, yeah, that's actually not that important, well then almost any neck turning implement out there will work, because we can kind of support the case however we want. We can cut using whatever implement we deem most efficient, and we can uniform our neck wall thickness. However, if we think that is important, and folks, I think this is the singular most important element to neck turning. Obviously, it's very important that we have a uniform neck wall thickness. But it is probably more important as far as our results downrange that the alignment, the coaxial alignment, the coaxiality and the coaxial alignment of our neck in relation to the base of our case be perfect. That is what I am saying is the most critical element here as far as it pertains to our performance on target. If we believe that, if you agree with me and you think that that is indeed true, now our choices for neck turning get awfully small, and I mean infinitesimally small. Because if we do not have access to a big CNC turning center or a full-size lathe or something of that nature, then we physically have no tool available to do this, with the exception of one, and that is the F-Class Products AutoDOD. And I say the AutoDOD, the iDOD can obviously do it as well, but the additional power of the CNC control, right, the ability to precisely control kind of our speeds and feeds, if you will, can reproduce an effect with much more repeatability than a human being can. So the iDOD obviously is the manual version of this. The AutoDOD is the CNC automatic driven version of it. The variables that count here in neck turning, the AutoDOD takes care of all of them, and does so in a very elegant fashion for a machine that is priced that someone can actually get into, right? Now, a lot of you out there, you have manual lathes in your shop or in your garage, and I'm not going to tell you that you couldn't foreseeably set up your manual lathe to do just as good a job, or a manual lathe with digital readout, or maybe you have a CNC lathe, right? If you have that big equipment, hey, you can set up that big equipment to do neck turning and do it correctly to ensure that this coaxial alignment issue is resolved. However, if you do not have that equipment, well then you're faced with a very daunting choice, because most people do not have the power or the space to store a large lathe. Now I can tell you folks, if you think that you can get one of those little benchtop lathes, like from Harbor Freight or something, for $500 or $1,000 or even $1,500, and outfit that thing to do a better job than the F-Class Products AutoDOD can, you are setting yourself up for massive failure. So I hope none of you have had that idea, and if you did, I wanted to stop you right there because many have tried and many have failed. The amount of money that you would spend would vastly eclipse the price of the AutoDOD, which is, I think, somewhere around $2,500 or something like that on the bottom end for the iDOD. And then I think the CNC automated version is just slightly more expensive than that. But I encourage you to go to the F-Class Products website and check out the pricing for yourself if you're interested. But the lathe guys that have your own equipment and stuff, I mean, feel free to go set up and try this. You can test this stuff yourself. The rest of you that don't have access to that equipment, well, the Autodod and the iDod are literally the only pieces of equipment out there that will do this neck turning job and take into account the coaxial alignment, because this tool is not a pilot-driven tool. Almost every other neck turning implement out there relies on a pilot that goes into the neck. That pilot then is what holds and indexes the cutting tool. And so it is using the through bore of the ID to allow you to uniform the thickness based on cutting the OD only. And there are many things wrong with this, right? One of the things that's wrong with this is the fact that you're putting a pilot inside the neck of your case. Anytime you stick an implement inside the neck of the case and then rotate that case on the implement or rotate that implement in the case, you're going to be creating friction, right? I don't care how much lubrication you use or what kind of lubrication, eventually those things are going to heat up. And trying to keep them at the same temperature to make sure that the expansion and contraction properties of the material that the tool itself is made out of, that the cutters are made out of, that the brass gets subjected to, will create a wandering and shifting tolerance. It is a ever-moving target. Trying to neck turn to within, say, 2/10,000ths on those piloted traditional neck turning tools is next to impossible with any regularity. If you were to try to do it across 100 cases, your cull rate, if you were unwilling to accept anything over 2/10,000ths in variance, your cull rate will probably be something like 30% or more of your cases, depending on how skilled you are. Obviously, the most skilled out there, very, very skilled operators can probably do considerably better than that. But the forces that are at play here, the compounding error, the thermal conductive, the surface lubricity, the material metallurgy, the folks, every possible variable that you could possibly throw into a cutting process gets added into trying to neck turn using these styles of implements. So it is just not something that I recommend anyone do. If you're going to neck turn, you should either purchase the iDod or Autodod, or you should send your brass away to a brass processing facility that has an iDod or an Autodod or some large-scale CNC machining capability that will be able to do just as good or better a job. I hesitate to say that someone could do a better job. On average, folks, the brass that gets turned out of my Autodod is within 2 to 3/10,000ths of neck wall thickness variance from around the entire circumference from the top to the bottom. So I couldn't envision the kind of effort and expense that it would actually take to better deal that machine. Now, there has been a few people that I have heard about that purchased an Autodod or an iDod, and they have not had good success in setting it up. And if you don't understand how to use this equipment, then it will be almost useless to you. So if you don't understand things like cutter flex or spring back of material, or, I mean, basically, you need to have some basic working understanding of machining terminology here in order to cut material in the way that we describe. Now, those of you that have seen our 4-part series on brass trimming understand how this hand-loading community can often refer to extraordinarily complex things in very simplistic ways. Who would have ever thought that I could produce 4 20 to 40 minute long, or I don't even know how long some of those videos were, but they were extremely long, detailed videos about trimming brass. It seems so straightforward. Well, to a certain point, everything in this discipline is very easy to understand and very straightforward until we get to the highest plateau, right? Once you get to the highest plateau and you're working on the outer limits of what this discipline can offer in terms of performance on target, then the demand on you of what you will understand and how you will treat these various components gets skyrocketed into it's difficult to even describe, because you could literally spend every day, all day, for the rest of your life on this discipline and not run out of these types of things to uncover or discuss. Because each individual element of it, the more you understand about one, leads to more questions in the other. So as you progress through the discipline, you will find these various things. So it is very possible for someone to purchase an Autodod and not be able to get it to produce a valid result, a good result. You could be running your cases through here, and you'll actually take cases and make them worse by not learning how to properly set the tool up. And so I could create an entire another video on how to use and set up an Autodod, and I think I may do that at some point in the future. For the time being, however, I would say that F-Class Products YouTube channel has some pretty good content on this. And they've got a number of videos that deal with how you go about setting up the tool to make sure that you're going to be delivering the best result. And they do some pretty highly detailed explanations as well on if your brass is bad enough, then basically there's no fixing it, right? If you are mangling the brass in other areas of your process through your incorrect sizing or incorrect mandreling or these different things, then you could theoretically mangle your brass bad enough to where even the Autodod cannot fix it, because the coaxial alignment problem is worse than the available thickness of your necks that you have to trim. So in order to fix the coaxial alignment problem, you would have to trim off a huge portion of brass on the bottom of this side and a huge portion of brass on the top on this side. And were you to do that, you'd basically oblong the case mouth, right? It would completely destroy the brass. So there is such a thing as having brass that is bad enough that neck turning it right like that wouldn't fix it. So if you can, right, you would fix it a different way. So first I wanted to get out of the way that simply purchasing an Autodod doesn't make you a brass turning wizard all of a sudden. You will be expected to know some of this stuff, and it's information that's readily available. Okay, nobody is hiding this information. Not machinists that are used to using cutting tools to turn brass and various other metals, and certainly not F-Class Products. And then I have a tremendous amount of experience with my Autodod as well, and will happily help those of you that are enrolled in our mentorship program to unpack and work with your Autodod and get it set up correctly. So feel free to reach out, those of you that are in our mentorship program. If you've got an Autodod or you're thinking about getting one and you have some questions, or folks, that's what that resource is available to you to use. So if you find yourself over your head in this neck turning thing, feel free to give me a call and I'll see if I can help you through the weeds a little bit. There is so much here, folks, and this is why I hesitated to make this video, is because this is the kind of thing that will often take 5 or 6 or 8 multi-hour phone calls for those people in my mentorship to really fully understand. And they have to be actively doing it. and they have to be actively loading for the rifle and actively shooting the rifle in order to finish the bulk of these conversations, because it requires a high-level understanding of just about everything that's going on here in order to really figure out how to properly go about doing it. So that brings up when. When should we neck turn? Let's say you've decided to neck turn. You've decided to invest in the auto dod and or the iDod, and you've decided that you're going to pursue this to its fullest capability. Well, when should we neck turn? Now, some people say neck turn virgin cases. Okay, straight out of the box, brand new brass, and you should neck turn there. If your brass is of a good enough pedigree, you can probably get away with this. Conversely, if your brass is not very good and it's not individually packaged, meaning that the brass is jostling all around, banging into each other during transit, well, then there's a very high likelihood that a lot of your brass will have peened necks or rolled mouths or dents in the side of the neck. Folks, if you don't have a perfectly round neck, then trying to neck turn it with a dent in it or some other deformity is going to be basically impossible, right? So I would not recommend that. In some instances, individual batches, lot numbers of brass, or brass from manufacturers that individually packages their different pieces of brass. A lot of times you can get away with neck turning right out of the box. And sometimes it's even beneficial to do that, especially if you're somewhat novice in your capabilities in the other stations, right? Because you can ruin your brass before you try to neck turn it if you're not careful. Those of you running neck turn chambers will have no choice but to neck turn this stuff right out of the box. However, if it's broken, you can fix it, right? So let's say that you take your brand new brass and you wanted to neck turn it. Well, the thing that you would need to do is mandrel it. Now, you have to be really careful in order to do this. You can also accomplish this with a full-length sizing die, and I recommend using a full-length sizing die if you have one, especially a full-length sizing die with an expander mandrel, such as those that I recommend from Shore Action Customs, because you really don't want to mandrel a case, right? Push a mandrel into the top of the case without supporting the rest of the case. And the reason why is because when you're pushing on that case mouth, that stress and that force is going to go somewhere. We know we can't neck turn the brass with a dent in it. We know we can't neck turn the brass with a ding or something like that. So we need to get the dent out of it, and that's why we need to put it through a process here. So either expander or a full-length die with an expander, right? So if all you've got is an expander die, knock yourself out. You know, you might push a coaxial alignment problem into the neck unknowingly. It's possible. You could create a neck to body runout problem. That's possible. And again, you know, runout being like the umbrella term for all of the other terms, essentially. The issues that you can create when trying to process and fix the brass in order to get it neck turned can actually create a lot more problems. If you're expanding it, you're obviously working the brass, which will increase the brass's hardness, which maybe will make it neck turn worse, or maybe it will make it neck turn better, because the speeds and feeds here on how we're running our cutting tools on this brass is largely dependent on the hardness and the characteristics of the material that we're cutting. So you you see here how trying to make a video on this topic, folks, is almost impossible. At least a video that is correct. I could mislead a bunch of you and create a neck turning video that's whiz bang and flash, and it's really easy to understand. But as we go through this, the number of compound variables that come into play is just unbelievable, right? So, the expansion op, right? If you can support the case when expanding it and fixing the dent in the case, that's good. If you wanted to anneal it before you did that right out of the box to fix the non-uniform stress in the brass neck, like just the fact that it's dented, folks, there's a dent there. That dent put some movement into the brass. When the brass moved, it changed its hardness, at least to some small degree. If you're turning a case and the cutter is running around this thing, right, and it gets to the hard part, it's going to potentially resist the cutter more, driving the cutter out more, right? So even if you turn it and let's say you mandrel it, but you don't take care of the hardness problem, well, you're going to turn it, but it won't turn perfect because it'll be harder there where the bump was that got pressed in and then subsequently pressed out again. It'll be harder where those stresses were than the other side of the brass. So the cutter will not cut on it the same way, thereby you will cut a non-uniformity into the circumference of the brass. Now, because you've neck turned it, you won't be able to neck turn it again to fix it. Because in order to get a precise cut, you have to be removing a relatively significant amount of material. You can't just turn 2/10,000ths of an inch off of this brass. It is too malleable, and it will have every bit of probability of just smearing when it encounters the cutter than it does actually getting cut off. So in order to make a very tight tolerance cut on any material, I don't care if it's brass or anything else, you have to be removing a amount of material that's relatively thick in relation to the tolerance that you're trying to hold. So here, we're only taking off, like if we started at 15 thousandths and we're going to 12, that's only 3 thousandths. 3 thousandths is just not that much. Now, if we look at 3 thousandths off of both sides, right, because we're turning the neck wall thickness down 3 thousandths. Well, we've shrunk the diameter by 6 thousandths, right? 3 thousandths per side. And that's a pretty common cut, right? Obviously, if we try to take less than 1,000th, well, then it can be very complicated, and this hardness issue that's created by the dent will be even worse. So maybe the best thing to do is to take the brass out of the box from the factory, anneal it, or fix the dent and then anneal it. Now, if you fix the dent and then anneal it, will it still be round? Or will it be oval shaped now, and you'd have to run it through your sizing die again in order to have the most consistent hardness around the circumference from the top to the bottom that will actually allow it to be cut most uniformly. Now, I chuckle at this, folks, because it's like, at this point, many of you are thinking, yeah, I'm not going to neck turn. I am just not going to do it. And that's perfectly fine. I respect that decision, right? This neck turning thing is one of those things that once you decide to do it, you have made a commitment to do it right. And doing it right is possibly one of the most complicated things that a hand loader will encounter, because there is no equipment that you can buy that will remove enough of the burden of knowledge on how to use the equipment correctly, right? There's no equipment made that will remove the burden of knowledge. Now, there's a lot of equipment made that almost entirely removes the burden of knowledge, right? You need to know a little bit, but not very much. And just owning it and using it in the prescribed manner is enough, and it will solve that variable in your process almost completely. Folks, this neck turning thing is not one of those. You could buy the best equipment in the world. You could spend $150,000 on a perfectly awesome CNC turning center. And if you don't know this about material hardness, cutter spring, the spring in the material itself, all of these variables that I'm unpacking for you here on this video, then you would never be able to get the best result out of that equipment. It is incumbent upon the operator to know this stuff and use the equipment to deliver the intended result. And you can't just say, oh, I'm going to put my head down and head for the horizon on this thing. You have to be able to check it along the way during the setup and then spot check it through, either each case individually or spot check individual cases as you're running through your batch to make sure that the equipment is not drifting, right? And that your cutters are still sharp, that you're... Anyway, so maybe we decide that we're not going to do the virgin brass, right? Maybe you decide that you're going to neck turn after you fire it. Because when you fire it, the case gets pounded against the bolt face, the brass expands to fill the chamber, and if there's a coaxial alignment problem, well, the act of firing it probably fixed it because it mashed the case head against the bolt face and then blew the chamber out. And because now, as long as your rifle's been chambered correctly, the brass is going to take the shape of the chamber, roughly. Now, how hot a load you're running and how many firings this will take to have the brass be perfectly representative of the size of your chamber and the configuration between your bolt face and your chamber. I have much other content on that you can go check out. But, so say that fixes it. Okay, you go to eject the case, right? Your spring-loaded ejector bangs the mouth of the case up against the front band on the front of your ejection port, or through ejection, it spins around and smashes into the mouth of the case, gets smashed into the rear band. Now, I don't know if you guys have seen some of my rifles. They have countless little dings in the Cerakote and dings on the action where thousands of rounds of cases have flung out and bashed against the rear band there. But that's what that little half moon little mark on the rear band of your action is from, if you haven't noticed that. Well, what do you suppose that does to the roundness of your mouth, right? Puts a big dent right in the side of your case. So if you're going to fire the cases in order to fix them before you neck turn, that's one of the variables you'll have to counter. And if you have a spring-loaded ejector plunger, obviously you can just remove it. Remove the spring, reinstall the plunger to provide the support for the base of the case, and then shoot the cases and fish them out of the chamber or fish them out of your action manually. Obviously, you can leave your extractor in there to pull the thing out of the chamber, but remove the ejector. Those of you with manual ejectors, you won't have to worry about that. When you open the bolt, just bring it to the rear gently instead of engaging your manual extractor. So just bring it back gently and fish it out of the action manually. There's another issue that you're going to have to contend with, and that's the buildup, the fired case residue, right? The propellant residue on the case. A lot of times that stuff is very hard and very abrasive, and it's not something that you really want to be subjecting your precision cutting tools to. We're cutting a relatively soft material, and some of this residue can be very abrasive and very hard. So you'd want to use a good abrasive brush the residue off the inside of the neck, and then use something like a Scotch-Brite pad or something to take the residue off the outside of the brass. Fixing it with firing and then taking the proper precautions and steps, that is actually a very good idea. And so if you're not running a neck turn chamber and you can get past your first firing and essentially fire form the cases and then neck turn, well, that can oftentimes be a really good idea to fix these various coaxial alignment and runout issues. Now, I have had fantastic success turning virgin cases from certain manufacturers, and I do a visual inspection of each individual case neck to make sure that there are no imperfections and dings that I need to concern myself with before turning it. And is often the case with a lot of my Wildcats. I need to go through a fire forming operation anyway. And so I use the measuring implements that I have to make sure that when I set up for neck turning, that I am properly doing it. If I find that the brass is simply not capable of being turned out of the box new, well, then I'll do a fire forming operation and get it turned then. Now, I mentioned briefly you could go ahead and resize the cases, right? After firing, you could resize them and then turn. Now, this is probably my least favorite because it is the most likely for the user's deficiencies in other aspects, namely their sizing and tumbling methods, to get in the way of proper turning. So how they anneal, how they size, what lube they use, what dyes they use, what tumbling methods they use, all of this can monumentally interfere with the shooter's ability to get properly turned cases. There is such a thing as absolutely wrecking the cases by doing this. And so it's not for the faint of heart to decide to do this. However, it is important to remember that the complexity of this operation and the problems that we're trying to solve as a result of it also means that what the right method is will be very situational. It takes just as much experience and knowledge as a shooter to determine whether you should, when you should, and how you should neck turn as it does to do the neck turning op itself. And obviously doing the neck turning op requires a lot of knowledge about the tools and about the measuring equipment, the machines, what we're measuring and how. But trying to establish when to do the neck turning op, that requires a tremendous amount of experience as a rifleman, as a shooter, as a hand loader. Because the different operations that you're subjecting the brass to in those different circumstances will oftentimes have a tremendous amount to do with whether or not you're going to be able to successfully complete the neck turning operation at all. And so using that experience and deciding when to do it is just as important as deciding how you're going to do it. Now, folks, it kind of goes without saying here that I have indeed found a tremendous net positive effect to neck turning. This is especially true of those rifle systems where I am trying to wring out the absolute most precision and accuracy possible. This is not to say that it is not possible to reach apex level performance with brass that is not turned. I don't want you to misinterpret or misunderstand what I'm saying here, in that you must neck turn in order to have the maximum performance that your rifle system can deliver. Point in fact, if you're purchasing Alpha Munitions brass or LAPO brass, that may not be true. If you are not neck turning on an Autodod or an IDOD, and instead you're using traditional turning methods, it's almost a certainty that you could take what would otherwise be apex level performing brass and ruin it. And so the simple act of neck turning by itself does not deliver the category of performance that I'm talking about here. The combination of all of the elements that I was talking about, so coaxiality, coaxial alignment, circularity, run out, basically all of the effects that I've described in this video, those things can be in their most optimal configuration on brand new factory brass. The best way to find out whether or not neck turning will give you a net positive in your shooting is to grab a bunch of high-end measuring equipment and dive into your batch of brass. Bottom line, if you can competently measure all of the effects that I've described in this video, then you can determine whether or not your brass is going to be able to deliver an apex level result. Now, there are some things that are much more difficult to measure, such as case volume. The thickness of the brass that is not in the neck is exceedingly difficult to measure effectively. So you can have a non-uniform area of your brass that's just not very easy to get a measuring tool into that can create some non-uniformities in your shooting. So don't be surprised if you have perfect necks, but the brass itself is not performing at an apex level because of a metallurgical problem or some dimensional problem somewhere in the case that you can't necessarily measure, or perhaps it's being created by some other process or piece of equipment that you're doing throughout your various hand loading processes. The key here is to be led by the facts about what you know about your brass and how it is performing on target. And if you are questioning it, and if you're constantly thinking that there may be some performance there that you're not seeing realized, then the only way that you're going to find out is by doing it. Bottom line, you might not notice the effects of neck turning immediately. They might not show up in the form of an immediate change in accuracy and precision. However, across multiple firings, you'll notice that the brass will be more stable across more firings. You'll have fewer flyers. You'll have a general ease of tuning that you might not have had before. So the bottom line is uniform brass is going to produce uniform results on target, all other things being equal. For our scripture reading today, I'm going to be reading to you from Isaiah, the book of Isaiah. This is in the Old Testament, folks, and specifically, Isaiah has been given a message by God for Israel. And if you, specifically, Isaiah 53 is what we're going to be reading from. And I can't think of a different scripture that deals with the prophecy of Jesus's arrival quite like Isaiah 53 does. And so we're just dive in here, right? Verse 3. He is despised and rejected of men, a man of sorrows, and acquainted with grief, and we hid, as it were, our faces from him. He was despised, and we esteemed him not. Now, here is Isaiah in the Old Testament before Jesus. Now, depending on which historical documentation you look at, this could be as 200 or 300 years before Jesus, or 700 or 800 years before Jesus. But it's not debated at all that this was before Jesus. And so later in this chapter, he goes on to describe this person whom he said we despised so much, right? And they hid their faces. They did not hold him in high esteem. This message that I'm sharing with you here today is about that of rejection. Now, it just so happens that the passage that I'm sharing is from the book that deals with the prophecy of the coming of Jesus, and Jesus' arrival then being the fulfillment of this hundreds-year-old prophecy that corresponds with the message of Jesus' suffering. So here is Isaiah speaking about the nature of the suffering of this man that were to come later, our Savior. And the way that Isaiah speaks about it throughout this entire chapter is stunning, because the Isaiah 53 is referenced many times in the New Testament. And so here we have this being spoken of in the past tense by Isaiah. in the Old Testament, and it surely has not happened yet, but it absolutely has happened for Isaiah. And I understand that there's probably many of you out there right now that are suffering. You're dealing with rejection. Something's not going right at work. Something is not going right with a friendship. And you might be wondering to yourself, why is this happening? And you're upset about the fact that this person is scorning you, or this group of people doesn't like you or won't have anything to do with you. And I'm here to tell you that that's actually not only okay, but if you're living a right life, if you are trying very sincerely to live a right life and having even marginal success at it, then it's very important that those people do not like you. And that the rejection that you're feeling and the way that you're handling that rejection is very much a part of how God will come to judge you for the way you've handled it. The fact that the rejection is there, well, if you've read any scripture at all in your life, you should know that good people are always going to be rejected by the world. And so you should expect and know that already. And this should serve as a good message to you if you're not aware of that. I'm going to go on and read a couple more passages here. So we'll skip a little bit to 7. He was oppressed and he was afflicted, yet he opened not his mouth. He is brought as a lamb to the slaughter, and as a sheep before her shearers is dumb, so he openeth not his mouth. Now, I've shifted here to the King James Version. Normally I read to you guys from the New Living Translation, which is just a little bit more palatable for people that aren't very familiar with the word. I wanted to read specifically from the Old Testament, specifically in Isaiah, and I wanted you to read from the King James Version, because the words that are used and the terminology that's used in the King James Version is typically better than what we'd find in a lot of the other translations. We lose some of the context in the modern language, so to speak. So moving on here, right? The moral of this is that despite these persecutions, Jesus was not loud about it. He didn't concern himself with trying to wail and lash out and cause a scene, if you will. In all the places where he was persecuted, he did so silently. He did so quietly. There's only maybe 1 or 2 instances where he was animated towards the persecution, but it was mainly a conversation, a somewhat private conversation between him and God, or it was in the shouting down of ne'er-do-wells that he was in the presence of. But the suffering he endured it willingly, and he endured it honorably. And he did it without raising a bunch of fuss. And so this rejection that you might be dealing with, these people that might have negative things to say about you, the persecution that you might be facing, the critical element is not that you're facing it. You have to understand that if you're facing it, then it will be used for the good if you are indeed a true believer. And then whatever that persecution is bringing, whatever that rejection is bringing, is required for something that you're going to need in the future. And so it's important to look from the proper biblical context and say, hey, whatever's going on right now, whatever you're going through, you need to be going through it. And if you weren't supposed to be going through it, then he would never have you go through it. So the fact that you are means that it's necessary. Once you understand that it's necessary, then you can also alleviate your pain from going through it. You simply put the salvation of your peace in God's hands. You stop trying to think your way through it. And you stop worrying about whether or not those people that dislike you are needing to be in your life. Because if they did indeed need to be in your life, then that's not something that you would have to do. And it's the last thing in the world that you want to do to raise a fuss and manipulate or whatever it is that you're thinking about doing to try to deal with that rejection on your own. Far better for you to give that over to God, let Him deal with it in the way that He sees fit. I assure you, whatever justice He will mete out is going to be significantly better than what you are thinking about doing. Which follows into this next verse here, so verse 10. Yet it pleased the Lord to bruise him. He hath put him to grief. When thou shalt make his soul an offering for sin, he shall see his seed, he shall prolong his days, and the pleasure of the Lord shall prosper in his hand. So basically, this is the ultimate fulfillment of the prophecy that Isaiah spoke about to Israel that was seen fulfilled in the New Testament when Jesus came, was persecuted, and subsequently was sacrificed for the rest of us. And so there you have the final conclusion of what happens to you when you suffer silently. Now, this isn't to say that you can't take into your closest confidants and you can share with them your burdens, and you can iron sharpens iron, as other scripture is meant to say. But it means that you're not to outwardly demonstrate your displeasure at what's going on. You have to have enough faith to understand that whatever is going on is good and or will be used for good. And if you can have that faith, well, the scripture also states that a peace that defies all worldly understanding will wash over you. So that is my wish for all of you watching this today, that if you're dealing with unpleasant circumstances, a loss, or some form of rejection, that you understand that not only are you not alone in your suffering, that God is indeed there with you actively in those moments, but that if you ask Him for it, He will give you the strength to see those situations through, and all you have to do is be willing to obey, maintain the tenacity of your faith to its utmost, to your utmost capability. Stay as close to Him as possible, and He will work out the rest.